All right, here's our video on exothermic and endothermic reactions. So just from the start, look at the word exothermic. It has the word X, right? Like the exit sign. So let's make sure our pen's working. And we'll stick with blue. So right here, that X means exit. That's going to be a key word to help you here. And of course, they all have thermic. So you have thermic here, meaning heat. So in exothermic reactions, the heat is going out. Heat is going out. So in other words, what they're doing in exothermic is they're releasing energy. Well, not they're releasing. It's not like there's a person. But exothermic, releasing energy. Think of exit sign. Or an endo means within. Means within. You might have heard of an endoscopy, where the doctor looks inside your esophagus, right? So here it's the opposite. Heat is not going out. Heat is going in. So it's absorbing energy. Absorbing energy. So let's take a minute and look at this so make sure we understand. So exo, think of that exit sign. Heat is going out, releasing energy. And endothermic, heat is going in, absorbing energy. Let's look at examples here. So the perfect example is cooking, right? When you're cooking, let's use red, right, for the heat. Heat is going in. It's going in. So, right, this is endothermic, right? We're talking about endothermic, absorbing heat. So heat is coming in with cooking eggs. That's easy to understand. And here in photosynthesis, right, the light energy from the sun is coming in, right? And a cold pack, well, usually cold packs, they have ammonium. They have ammonium nitrate. I'll write over here, ammonium nitrate. Ammonium nitrate. And what that will do is when you break an ice pack, the ammonium nitrate will absorb heat. By the way, this is ammonium nitrate. It has nitrogen. It has 4 hydrogen. Another nitrogen with oxygen. 3 oxygens. That's ammonium nitrate. They also use ammonium chloride. Right? You can also see it as ammonium chloride. All right. So anyway, what's happening here is the heat from your body, right, the heat's coming in because it's absorbing heat, right? So that's endothermic. Now with exothermic, let's give you a picture of that, right? The heat, like fire, right? The heat is going out. I use yellow, right? See the heat is going out with fire. And of course, with an ice cube, the heat is coming in and it's melting the ice cube. But you can also see exothermic reactions with sodium, for example. I'll show you a picture of that. So here's sodium, right? And now I'm talking about pure sodium now. And we'll talk about this chart in a minute. This shows you the reaction. But let's go back to that sodium. So again, I said sodium, not sodium chloride. When you're reading, let's say junk food, or you're reading something and you want to know how much salt is in it, they just say sodium, but they don't really mean sodium. They mean sodium chloride, table salt. But here I'm talking about pure sodium. Pure sodium, right? If you put sodium into water, into the hydrogen monoxide water, this is what will happen. An extreme reaction. It depends how much sodium and water you put in. So you can see this is exothermic because the heat is coming out. So again, remember, think of the exit sign. Heat is coming out. Heat is coming out. And endothermic, absorbing heat. So let's go to that chart you saw before. You might see these on tests. So with an exothermic reaction, notice right here, and we'll stick with yellow, see how yellow works. You have the energy, right? And that's also, it's liberating heat. It's freeing the heat. That's what exothermic, you'll get that word. Back to the chart now. I guess the chart doesn't want to stay today. All right, so back to this chart. You can see here's the energy going up, right? We use a better color. See energy coming up. So in exothermic, you can notice that there's a lot of energy to start, and you start losing the energy, and it makes sense you're losing energy because the energy is going out. Whereas an endothermic over here, right, you start off with lower energy, but the heat is coming in it. There's energy coming in, so that's why the energy increases. So try to remember how that works. Again, why is exothermic starting with a lot of energy? Because the heat is being released, an enormous amount of heat. Remember with the sodium and water? When the sodium and water reacted, there was a lot of heat. And slowly, and if you ever touched sodium and water in a beaker, you would feel the heat. But slowly over time, the heat it'll get cooler and cooler. So the energy is being lost. But in endothermic, the heat is coming in, so the energy is increasing. Just remember these two. So you saw this before also. Exothermic, again, is releasing heat. You'll hear your professor say, liberating heat. So, and you saw the chart. Remember, it starts off with heat, a lot of energy, comes up, and then it finally will lose energy. Well, in an equation, let's look at an equation. Let's look at a chemical equation. Let's say we had a carbon over here, which we know is a solid, right? And then we had O2, the air we breathe. Sounds like an ABBA song, right? And it will yield. So here is the first. These are, again, the reactants. And I'm sure you used this by now. And will yield carbon dioxide, which we know is a gas. Plus, now what? This is the plus thing. You always have to have the amount of energy of the heat. So remember, the heat is being released. And so you would see this in kilojoules. The kJ will be kilojoules. Kilojoules. Make sure we spell it right. Kilojoules. So if you see that the heat, the kilojoules, is on the right, that is exothermic because the heat is being released from these two products. The heat is being released. Now with endothermic, you'll see the kilojoules, the heat energy, on the left. So let's do one. Let's get that one. All right, we'll stick with purple. So let's say we had nitrogen. We had two elements of nitrogen, which we know is a gas. And, well, let's use O2 again, the air we breathe. Now, again, like I said, with endothermic, the heat will be on the left. So you'll see the kJ, and what does kJ stand for? Kilojoules. There we go, kilojoules. Remember, heat is measured, the amount of energy is measured in kilojoules. And that will, again, so this is the reactants. And these are the products. So again, remember with endothermic, the reason why the heat energy is on this side is, remember, heat has to come in order for you to get the products, which will give you this nitric oxide, which is also a gas. So here we have 2 moles. You might see, remember we talked about moles in other videos, without the E now, 2 mole of nitric oxide. Just a measurement of how much stuff we have, 2 mole of nitric oxide. So again, with endothermic, why is the heat on the left? Why is the heat with the reactants? Is because heat has to come in to form the products. Whereas when we talked about exothermic, we're liberating the heat. So the reactants will create that heat in the products. All right, let's go back to this chart here. And this part gets a little confusing for students. They've asked me this a few times. So let's make sure our pen's ready. What will we use? Let's use this color. Why not? So again, with the exothermic reaction, there's a lot of heat being released. So look at this over here. This is the activation energy. And that is the catalyst. That is the energy needed to jumpstart this whole thing. Now, in other videos I talked about, when we talked about digestion, you need enzymes to help you digest your food. And those enzymes are like activation energy. That's that catalyst you need. Without enzymes, you just would need so much more energy involved to digest your food. In fact, it just wouldn't work. You wouldn't have the energy to do it, and you wouldn't survive. So activation energy over here, I don't know if you can see, let me write it again. Activation energy. It's just a catalyst, just the energy needed to start this reaction. And you can notice that the active energy in exothermic is much smaller. Look at in the endothermic, and a lot more activation energy. So just review, exothermic is releasing energy, and that's why the energy is going down. But here's the weird part. The energy is going down, but in the reactants, the temperature is going up. Temperature goes up. The opposite's happening in endothermic. It's absorbing heat, but in the reactants, the temperature is going down. And you're saying, well, why should it go down if it's absorbing all that heat? Well, think of it as like an ice cube. If we had an ice cube here, let's make a little weird ice cube, who knows? And we drop this ice cube in this water. Let's say the water was at, well, let's say it was at 70 degrees. You drop the ice cube in here, it's going to make the water cooler. The temperature will go down. And remember, ice cubes, right? Heat is going in. It's absorbing the heat. So it absorbs the heat. Everything around it gets cooler. So two things to really look at in exothermic reactions for a test. Just remember that it's being released. You remember the exit sign. Heat is being released. Endo, heat is being absorbed. And the temperature goes up. All you have to do is do an experiment, put sodium in water. You'll feel that heat. And in endo, the temperature is going down. All right, so that is exothermic and endothermic reactions. Oh, and just one more thing. All right, just when you thought it was over. So just again, these charts are important. So you look at the energy of the products here. The energy of the products. In the exothermic reaction, the energy of the products is less than the energy of the reactants. I mean, you can see it. It's obvious. Like, look at that. And again, it's opposite with endothermic. The energy of the reactants is much less than the energy of the products. All right.